Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined again by Dr. Kevin Mitchell, Associate Professor of Genetics and Neuroscience at Trinity College Dublin. And today we're going to focus on his new book, Free Agents: How Evolution Gave Us Free Will. And I'm also leaving our previous conversations in the description box of this interview. So, Dr. Mitchell, welcome back to the show. It's always a pleasure to talk to you.
Well, thanks very much, Ricardo. It's my pleasure. Thanks for having me back.
Okay, so since we're talking about free will here today, I would like to start by asking you this because, traditionally, I guess that people tend to associate free will as a question that would be primarily tackled by philosophers. But in this case, you as a neuroscientist, and there are other scientists out there from physicists to psychologists nowadays tackling this issue. In what ways do you think that someone coming from the sciences, particularly the behavioral sciences, has to offer to this debate that probably philosophers can't?
It's a great question, right? It's a perfectly good challenge to say, who do you think you are? Coming to this debate that great minds have been engaged in for thousands of years, and it is something to give a reasonable person pause, I think, before jumping into it. But the reason I think that, or what I think, neuroscience in particular has to offer is all of the things that we're learning about the neuroscience of decision making and action selection and agency and control, behavioral control in everything from the simple organisms all the way up to us. And it has seemed to me that a lot of the debate that happens in the purely philosophical literature, it doesn't have as much contact with that empirical literature as it might, right? I mean, if you're talking about free will, you're talking about decision making. We're talking about selecting actions. We know an awful lot about the science of that. And you can have these discussions about free will just in the abstract, just in principle, or you can try to ground them in the practice of what we know, experimentally, and our increasing understanding, I think, that we're getting from science. And of course, then the danger is that you need to look at that scientific stuff and you need to try to interpret it in a philosophically sophisticated way, right? I mean, I'm not suggesting that we just ignore all that philosophical work that's been done. One of the problems, I think, and part of the reason that I wanted to write this book was to push back against what I take to be somewhat naive interpretations of neuroscientific data that say, well, look, something's going on in your brain. We can see what it is. We can tweak it. We can watch it happen. We can push it one way or another. And all of that shows that really it's just your brain making decisions, not you. And that kind of thing is a bit of a simplistic view, in my opinion. So I think, there's a happy marriage, hopefully, of philosophy and science where the two of them are informing each other and deepening the conversation as opposed to being in any way kind of antagonistic.
Mm-hmm. I know that this kind of question sometimes is a bit annoying, but do you think it's important to define free will, to have a definition of free will to really be able to tackle it and its existence or non-existence? Because, when you get into it, sometimes the way people define it as, supposedly being about being able to make any sort of decision without any sort of constraints. Sometimes we might get into religious territory or spiritual territory where, you don't really want to take into account what's happening in the brain or any other sort of influences you might get from your environment. It's supposedly this sort of thing in the Cartesian tradition where it would be completely separate from anything physical for you to be able to be completely free to do something or to make a decision. But that's one view. There are other views. But do you think it's really important to have a definite or a proper definition of free will or not?
I think it's actively problematic to start with a definition like that. And I think a lot of debates do that, right? So they'll start with a definition like the one that you just said, which is very absolutist and really kind of dualist, right? It's suggesting you have free will only if you are free to do whatever, take an action that is uncaused and unconstrained by any prior cause whatsoever, right? I mean, that's the absolutist sort of definition. And if you think about that for any length of time, first of all, yes, it's really dualist. You're asking for some kind of immaterial causation. So it's supposing something that couldn't possibly exist under a typical scientific materialist view, right? And then secondly, if you think about it even more deeply, there's a kind of a question of what would that entail? What kind of a being would behave in that way with no prior causes whatsoever? Because it means you're not paying attention to anything, you haven't learned from anything, you don't have any motivations, you don't have any goals. All of those things are prior causes or constraints, but they're all, in a way, good constraints, right? I mean, those are the things that guide our behavior adaptively. If you were just one of these absolutist free will organisms, that is just basically you'd just be a random behavior generator, right? You'd just be doing things completely randomly, because if you say no, you're doing it because you want to, well then you've got this, okay, well that's a cause. Me wanting to do something is a cause. So I try to avoid that approach in the book of starting with a sort of a textbook definition like that, and rather kind of say, well, what's the phenomenon actually that we're interested in? And what's the problem around that phenomenon? And for me, the phenomenon is our everyday experience of making choices. Right? We go around, we make choices, we do things for our reasons. We often can say what those reasons are. We know about them. We can think about them. And we seem, at least, to actively make decisions on our own. And we, therefore, are the causes of things in the world. And I think that's true not just for us, but for other organisms as well, to varying extents. So if that's the phenomenon, that's what it seems like, that's our everyday experience, the challenge to that is that maybe that's an illusion. Right? Maybe all that seeming control that we as the sort of top level selves have over that process is really an illusion. Maybe all that decision making is just neural circuits churning away. Right? And as I said earlier, the danger as we learn more and more about the neuroscience and mechanisms underlying decision making and action selection, there's a temptation to say, well, it's just mechanism, right? I mean, I can see it. There's the neural circuits firing. That's what caused the animal to do this. That's what caused the human being to do that. And in that picture, the organism as a whole is being pushed around by its parts. And what I want to see is, can we get to a sort of a naturalized view where we can defend the position that actually, no, it's really the whole organism that's in charge. It's not its parts. It's in control of its parts. And that, for me, is the sort of challenge that I wanted to try and meet. And the approach to do that was to take an evolutionary approach, starting with really simple organisms.
And we're getting into that evolutionary approach in a second. I mean, later on in our conversation, we might get back to this question about how we think about and define free will, because there are some challenges to the view you present or the approach you present in your book that come from other scientists, particularly neuroscientists like Robert Sapolsky, that I think are worth tackling because they are more serious than just this dualistic kind of way of thinking about the brain and the mind and so on. So, but why is it that in the book you go, when it comes to understanding, evolutionarily speaking, how free will evolved, I think we could say that, why is it that you go all the way back to the origins of life on Earth? I mean, why do you think it's important to go all the way back there?
I know it is probably a strange thing to be reading a book around that's ostensibly about free will and then suddenly have a paragraph about where life came from at all, and talking about the earliest life forms. So the reason for me was to couch our understanding of free will, which was we can say is present in humans. That's what I would argue,
Yeah.
in the context of agency more broadly. And agency more broadly is just the ability of living organisms to do things, to act in the world, to be causes of things, not just to be pushed around by things in the environment or outside them, and not just to be pushed around by things inside them either, right? So if you want to get to that notion of agency, for me, really, it's absolutely the fundamental property of living things. It's really one of the key things that separates living things from non-living things.
Right.
I mean, simply put, a rock can't do anything, right? It doesn't do anything. Planets don't do anything. Things happen to them and near them, in them, but none of that could be called an action, right? So, so to think about what is it that allows living systems to do things, that's really why I wanted to go back to ask, well, what is a living system? What does that mean? And part of that, the picture I'm trying to show is that living systems are not just static arrangements of matter. They're dynamic arrangements of matter. They're processes that are happening that require some energy to keep those processes going, right? I mean, that's what a living thing is. It's a pattern of processes. It happens in our world that it's chemistry, right? It's chemical processes, biochemical processes.
Right.
It doesn't have to be necessarily in theory, but in practice, that's what it is on Earth. And those processes are, thermodynamically speaking, unlikely, right? I mean, living things hold themselves out of equilibrium with the environment. So they're having to do thermodynamic work to keep themselves organized in this thermodynamically unlikely way. And as a result of that, if you think about that fundamental property of life, that it basically grounds an idea of life having a goal, and the goal is to persist. And it's a sort of a tautological argument in that the things that are good at persisting persist, and we see them, right? And the things that aren't don't, and we don't see them. So, so that persistence, right? That having that goal of persistence is enough, I think, to ground two other things that we really need to understand agency and free will, which are value and meaning, right? So if you want to say, I'm doing things for reasons, or an animal is doing things for reasons, then that's a different kind of causation from simple physics. It's an informational causation. So what that means is the animal has to have some information about some state of the world, some state of itself, and some state that that it would like itself to be in, so a goal, right? And things in the world then have value and meaning relative to that goal. So the purpose of starting with the origin of life is to ground those concepts, which are otherwise difficult, to naturalize. So concepts of meaning and purpose and value, on which I think that framework of free will and agency has to be built.
And when it comes to informational causation, I mean, the first step in that, would it be related to the evolution of genetic material, like first RNA and then DNA? Because that's something where information is stored over time, correct?
Yeah, I mean, I think you can go even before the idea of genetic material.
Yeah.
You got information in the sense of an organism that is trying to persist, and there may be something in its environment which is a threat to it or an opportunity, and it should either approach it or avoid it, for example.
Right.
And so that's what I mean by sort of informational causation, where you've got an organism that is insulated physically in terms of physical causes. It's insulated from the environment. It's not being pushed around by every physical thing in the environment. There's a barrier, right? But across that barrier, the organism can get information about what's out in the world, and based on its internal configuration, it can do something about that, right? And usually it can do something adaptive about it. Yeah. So that's what I'm talking about in the first instance about informational causation. Okay. However, you're absolutely right that over time, organisms, I mean, you have to ask, well, why is the organism configured that way? To go towards a good thing and away from a bad thing, right? Yeah. How did it get that way? And then you're into questions of causation that's extended through time, right? You're not just asking in a moment what triggers this response, you're asking why is the organism structured in that way such that this triggers this response. And then you're into evolutionary causation and learning.
Okay.
So you can think of evolution as a learning process. It's a slow one that goes by trial and error and sort of random search and selection over time. And it can configure what we could call control policies into even the biochemistry of simple organisms like bacteria. But you can also think of learning in animals that evolve nervous systems where they're doing that same job. They're understanding, learning things about regularities in the environment, what's a good response, what's a bad response, but they're doing it over their own lifetimes. And the substrate in that case is not the genome, that controls the biochemical configuration or the development of the organism, it's the structure of the nervous system itself, the anatomy of the nervous system that reflects those memories.
Do you think, I want to ask you this because I'm very curious about it. I've talked with evolutionary biologists about this specifically, but I want to hear your thoughts. So when it comes to the origins of life on Earth, do you have any bet on the race between the metabolism first hypothesis and the RNA world hypothesis?
Yeah.
And does that even matter for the kind of argument you're making in this book or not?
It doesn't really matter that much. And I present in the book a scenario that I find the most appealing and the most likely, and it's one that involves life evolving near hydrothermal vents, but warm ones, not really hot ones, where there's a supply of hydrogen and carbon and carbon dioxide. There's a free energy gradient, and there's little micro compartments in which things can be concentrated long enough to make complicated hydrocarbons and so on. And so, in that view, it is basically a metabolism first view, is that you would get some series of chemical reactions that can form a kind of a self-enclosed or autocatalytic set, right? So they can keep themselves going as long as there's a supply of raw materials and a supply of energy. And in that scenario, at some point, that system might have generated its own barrier. So rather than being stuck in some rocky little crevice, if it creates, say, lipids, then it might make a lipid membrane that might make a free-floating kind of organism. And so, it's, part of that is just speculation, not speculation on my part. It's theorizing on the part of others, like Bill Martin, for example, and Nick Lane and others. But I find that quite compelling. And in that view, the genome would come sort of later, right? So it would be, you could have these things that are just persisting as sets of chemical reactions. However, you could argue that they're a bit precarious, right? They're a bit fragile. If something pushes them out of their system, they may find it hard to get back into that system, right? And that's where having some genetic material as a kind of a record or a template of the desired configuration of all those elements can be really useful, because even if you get disturbed in some way, that you can kind of refer back to that genetic material as a resource in the cell to recalibrate all those things. And then, once you have that, the other great thing about genetic material is you can replicate it, you can divide a cell, and then you can reproduce the phenotype from that information. So for me, that's a plausible kind of origin of genetic information, and it highlights the important sense in which the information in the genome directs the configuration of the cell in an adaptive way that enables its persistence.
Well, I have to tell you, of course, I'm not an expert in any way when it comes to the origins of life on Earth, but from the conversations I had on the show with evolutionary biologists, I also tend to agree more with the metabolism first hypothesis than the RNA world hypothesis, but that's just my, I guess, informed opinion. So, by the way, at a certain point there, you mentioned things like meaning, value. These are some complicated concepts that people many times do not like to see applied to things like evolutionary biology. And another concept like that is purpose. So do you think it makes sense to say that life has a purpose?
Yeah, I think it does. What I don't think makes sense is to say that evolution has a purpose, right? That there's not some cosmic purpose, that there's some, that life has a meaning in with a capital M in the broadest sort of sense. That's not what I'm talking about. I don't think evolution has a purpose, but I think it creates organisms that have a purpose, and that purpose is simply to persist. And again, it's a sort of a tautological, pragmatic definition, right? I mean, it's just something that's an anchor to which we can refer that gives a normative value to things, in the sense that for an organism that has the tendency of persisting, some things will be good for it, say to approach like a food source. Other things will be bad for it to approach, say, a toxic chemical, right? And if you don't have some purpose that anchors that, then you don't have, there's nothing to anchor that normativity, because it has to be good or bad for something relative to some goal, right? So I think it absolutely makes perfect sense to speak teleologically about living organisms, because that's one of the key factors that differentiates living from non-living things, right? Rocks don't have goals, planets don't have goals, but frogs and cats and antelopes do have goals.
Right. And one of the big steps in the story, of course, I'm calling it a story, but it's not a fiction or anything like that. The story you present in your book when it comes to evolution has to do with the evolution of decision making and the need for things like sensors and perception. So why would you say that's an important step in the case you're making here?
Yeah, well, so you can think about organisms that, like I said, they're trying to persist as some sort of ongoing pattern of chemical reactions, right? And if the environment is perfectly stable and they have a supply of energy and raw materials, and they're getting, the environment is getting rid of the waste products that might be toxic, then fine, your organism can just sit there. Maybe if things change, it might reconfigure its internal metabolism, like some species do when they switch from so that's a good way to do homeostasis, right? To keep your inner system working to the set points that are desired.
Right.
However, another way to do homeostasis is to recognize that sometimes when things in the environment change, you can't just get adapt to them just by changing internally. A good thing to do is to move, right? And then you're all sorts of things. One is, when should you move? So you can have a decision, move or not move. And then you want to know, well, under what conditions should I move or stay? And then it becomes good to have some sense of what's out in the world. So for example, if food supplies are getting low, then it may be a good idea to move. And some organisms, some marine organisms do that just by letting go of a rock that they were attached to and letting the ocean currents take them. So they're not moving in a directional way, right? They're not deciding where to move, they're just deciding to move. But it's still a choice. Often it's a kind of explore, exploit trade-off. However, other organisms may make a more sophisticated decision, which is, okay, I'm moving, but now I want to know where to move. I should move towards this thing and away from that thing. So those are approach-avoid decisions. And again, to do that, you need some information about what's out in the world. So this thing that's insulated, right, from the environment, the world somehow, that can detect things. And the earliest things like that were chemoreceptors, like the things that we smell with, basically. And then later on, we got hearing and vision, which are more distance senses. So so being able to know what's out in the world becomes really valuable. And then, in order for that to be effective, you have to have a system internally that allows you to make some choices about what's out in the world, right? And what you should do about it. And oftentimes you have, most organisms, even the simplest organisms, have a repertoire of actions that they could take. So for a bacterium, to take one of the simplest ones we know about, it can, for example, rotate its flagellum clockwise or anti-clockwise. And when it goes one direction, it goes in a straight line, and when it goes the other direction, it kind of randomly moves around and sets off in a new direction. So there has to be some way to control that, right? it can't do both at the same time, right? It has to make a decision. It has to choose one of those options. It means it has to implement one of the options in its repertoire and inhibit, in this case, the one other option. For more complicated things, it's inhibiting all the other options and doing just one at a time. That's what behavior entails, and that's what behavioral decision making really is all about.
So let me, before we move on to some other steps in this story, let me ask you this: what would you call an agent? I mean, what does agency mean for you from an evolutionary biological perspective? Because I was wondering if there's, for example, any point in evolutionary history where we could say that, okay, so from this point on, we have agents, and before this point, we don't really have agents. So, for example, would it be possible for us to say that some unicellular organisms are already agents or have some sort of agency to them?
Yeah, I think the latter way that you just phrased it is the right way to think about it. Have some sort of agency, right?
Okay.
I'm not a fan of this sort of,
of absolute,
a bright line and then saying
yeah.
these ones on this side of that line are agents and these ones are just not agents. I think it's much better to think about degrees of agency and even maybe kinds of agency because there could be different kinds, right? So for me, what the question of whether something can be thought of as an agent really comes down to whether it, the whole organism, can be thought of as the cause of its own behavior, the cause of something happening. Is it because the agent did it, or is the agent being pushed around by its own internal machinery, right? And that comes back to the point that we talked about earlier. And there's a lot of nuance to that sort of thing, but I would argue that even the simplest behaviors that we know in the simplest organisms, like bacteria doing chemotaxis towards a food source, say, they involve particular mechanisms that can be isolated within the organism and that can be experimentally manipulated one by one in controlled manner. But in fact, most of the time, the organism doesn't encounter the world in that way, right? It encounters all kinds of things, lots of different stimuli, and it has to integrate them. And so you can say, well, look, the bacterium's not deciding what to do. A signal hit its receptor that phosphorylated some proteins inside it that led to the signal transduction cascade, which phosphorylated the flagellar proteins, which made them rotate this way rather than that way. And that is the explanation, right? That biochemical cascade that caused the organism to move there. The organism didn't do it. And you'll see, I expect, the parallels even when we get to humans, where you're saying it's not you making a decision, it's this neuron that fired, and then this pattern, and then this part of the brain activated, and that's what drove you to do it. So for me, it's very much the same idea. Is the organism in charge of its parts, or is it being pushed around by its parts? And I think the story of the evolution of agency is actually the story of organisms getting more and more control, more and more levels of control, and ability to control themselves and the world over longer time frames. So, in a bacterium, you can isolate the machinery that's involved in that direct pathway. However, it's also the case that that pathway is highly context dependent and conditional on the state of all kinds of other parts of the organism. So that respond to things like the temperature and the osmolarity and cell crowding and what other things are out in the world. So really, the action that's happening is, I think, properly construed as the action of the organism as a whole, because it's integrating all this information in a highly conditional, non-decomposable kind of way to execute what is the most adaptive action under that scenario, right? It's not just one thing at a time. Life is an optimization problem. We're always optimizing our behavior given A, B, C, D, E, F, these conditions out in the world and within us at any time.
So, since you're a neuroscientist, of course, we've already touched indirectly on these when, for example, you mentioned their hearing and vision, but how important is the evolution of neurons and nervous system as a stepstone
Yeah.
in the kind of argument you're making in the book.
Well, I mean, it's really important, especially for a transition from organisms doing things for reasons that you might say are configured by natural selection,
Yeah.
right? They're not, what I just talked about the bacterium doing. The bacterium as an individual is not, that's not based on its own life. It's based on millennia before it, right? That's why it's configured in that way. So the structuring causes, in that sense, are, from generations back, and so that's a kind of a weak sense of agency, and it's not so individual or personalized. And to get to a more personal kind of agency, where an individual organism, you could say, it has more involvement in its own control policies, then I think the nervous system really is a fabulous invention, right? It's because, of course, you can learn, right? You can associate, and so on. It didn't, I mean, probably the nervous system started out as really as a motor control system, right? So you get multicellular animals that have different parts, and they have to be coordinated with each other for the whole thing to move effectively in the world. And once you get to be a certain size, trying to coordinate things through chemical signaling is just too slow, right? And you're just relying on diffusion and very slow chemical reactions and so on that aren't good enough to coordinate the whole thing. And the nervous system is really good at that, right? And not just because of the electrical signaling, but also because of the anatomical characteristics of neurons, right? They're really polarized. They can extend over long distances, so you can do long-range coordination without having to go through every bit in the middle. So probably the first nervous systems were involved in the coordination of muscle fields, myoepithelial fields, and those are probably like nerve nets that you see in simple creatures like Hydra and other kinds of like jellyfish and cnidarians and so on. So, but once you've got that, then you can say, okay, yeah, I can coordinate all my bits, but now in any given scenario, what should I do with all my bits, right? Which way should I move? And then you can hook those up to sensors, right? So now you've got the nervous system as a kind of a relay or a processing interface between sensors that are giving you information from the outside and the motor effectors that are going to allow you to select one motor action out of a repertoire of possible actions.
And related to the evolution of the nervous system, could you tell us about the evolution of the neocortex? I mean, what role did it play there? And particularly the bit related to how it allowed for the decoupling between or the decoupling of perception from action.
Yeah, so the evolution of the neocortex, which sort of characterizes mammals and which is particularly expanded in primates and especially in humans, is for me, I guess, the sort of the last big step, the last innovation in nervous system development and the evolution of agency. And if you think about what that structure integrates with, there's some older parts of the brain that are involved in, say, selecting between actions, getting sort of at least simple perceptual information and hooking that to the action selection system, along with, this is really important, systems like the hypothalamus and brainstem regions, which supply motivations, right? So given, for example, some signals that say, hey, I'm starving, find food, right? I mean, it's a motivating factor that is basically, you can think of it as part of the control system. I mean, if you were designing a robot, you could say, well, here's a fuel gauge, but I need that to be connected to the behavior of the robot to go and find fuel when it's low, right? So you think about a lot of those sort of systems like that. There's multiple drives that are relevant to an organism that are important depending on its current state. And there are opportunities and threats in the world. Those have to be weighted relative to these internal states, because food in the world is highly motivating if you're starving, but not so much if you're well fed, right? So you can see, like I said, that behavior is this big optimization problem. Now, in my view, what the neocortex allows organisms to do is to do those optimization, thinking over more complex scenarios, more variable, more to allow more flexible behavior. So it's not just a bunch of hardwired reactions like, oh, I should move away from a looming shadow, or I should stick my tongue out if I'm a frog, at a little moving black dot, right? You can configure those kinds of things, but they're not terribly flexible. And I think what characterizes mammals is a huge degree of behavioral flexibility. That's why they can, many of them can live in so many different sorts of niches and so on, especially humans. So so the neocortex is basically a kind of an expansion of the abilities to do this, figure out what's out in the world,
right?
Link it to your internal goals, but then also, really crucially, link it to memories that you can form about the properties of things in the world. So you can associate things. You can say, okay, that thing that looks like that is tasty and I can eat it, and that thing that sounds like that can kill me, right? So you've learned from past experience. This is where organisms with nervous systems develop their own goals and reasons, not just natural selection reasons. So yeah, I think it allows for much more sophisticated perception and linking to memory, where perception now is about sense making, right? It's not just about responding to individual stimuli or even integrating a small number of stimuli at once. It's about figuring out what is out in the world. And when you come to the senses of vision and hearing, we're not detecting things in the world. We're just indirectly detecting electromagnetic waves or vibrating air, right? We have to do a job. We have to do a job of inferring what's causing those things. Because the organism doesn't care about the photons hitting its retina. It cares about what they're bouncing off of in the world, right? Objects are there in the world. That's what's going to guide and inform action. So the neocortex is really good at that, right? So there's a huge amounts of the neocortex are devoted to perception, ultimately to understanding, well, not just understanding, but recognizing the objects that are out in the world and then linking that to our memory of those objects, our memories of situations, and our memories of past actions and how they turned out. So in this scenario, I recognize I'm in scenario A. The last time I was in scenario A, I did X, and it turned out really badly, right? So then I should do something this time. Or it turned out really well, so I should do it again. And that can be the origin of habitual behaviors, that kind of learning over time.
So I would like to understand a little bit better, why do we need self-awareness? What self-awareness is good for? I mean, we have an internal model of the world around us. Why do we need to include ourselves in that model?
Well, I think because we're part of that world, right? And so if things are happening in the world, some of them are caused by us and some of them are caused by other things. If we didn't have a good way to distinguish between those things, then we wouldn't have a good way to figure out, to learn from our experience, because we wouldn't know what was our experience, the things that we did versus things that just happened, right? So in the simplest sense, for example, you can think about a moving organism, and its visual information is changing as a result of it moving. Or it could also be that its visual information is changing as a result of things in the environment moving.
Right.
And both of those things are probably happening at the same time. And it's really important for an organism to be able to distinguish that, right? Am I moving towards that, or is that thing moving towards me?
Right.
And one of the ways that that's done in organisms like us is that when we're about to do a movement, we send a signal, the motor system sends a signal to the perceptual system that effectively anticipates the visual consequences of the movement and then dampens down the sensory response to them. So that we're not, the world isn't spinning every time you turn your head. That's because the control system has told your perceptual system to expect the visual frame to shift, right? So I think from the even from that really basic sort of need to distinguish your own effects of things that you did from other things that are happening in the world, it just becomes pragmatically really important to distinguish self from non-self. And there's arguments, the people like Fred Kaiser and others have made that really is the origin of subjectivity in terms of the feeling of subjectivity.
So let me ask you one question that I think a neuroscientist, or at least a cognitive scientist, is well equipped to answer, which is something that people sometimes bring to the table when they're trying to make a case for determinism, a case against free will. Why is it that when we are simulating possible courses of action, usually there are certain possibilities that spring to mind and not others, when I guess in the vast majority of cases there would be a near infinitude of possibilities?
Yeah, well, I think you've answered, in a sense, the question, right? So you've asked, why do some things spring to mind when there could be an infinitude of possibilities? The answer to why certain things spring to mind is because there's an infinitude of possibilities, right? So we need a system that is going to narrow that search space to suggest things that are possible things to do in any given scenario. Otherwise, we would be overwhelmed with this set of possibilities. So most of the time, in a lot of the scenarios that we find ourselves in, and this is true for many animals, we have learned from experience that there are good things to do, right? So we have not just a habit of action, we have a habit of thought. It doesn't even occur to us to do something else, right? Somebody says good morning to you, you will say good morning back, or hello, or hey, how's it going, or something like that, right? It doesn't occur to you probably to slap them in the face, or to poke yourself in the eye, or all these other things you could do, right? But you're not going to, because they would be stupid, right? So, so I think that you can think about sorts of behaviors like in a sort of a spectrum, right? Some of things we've learned over time, we've done the thinking already ahead of time. All this past experience, we've learned to say good morning back when someone says good morning to us, right? We don't have to think about it. We don't have to waste effort on it. It's really efficient kind of thing, right? A lot of our behaviors are like that because we've been paying attention to the world and our actions and their consequences. So, so that's good. When people often talk about habits like they mean bad habits, right? They mean, I'm not really, I didn't consciously decide to do that, so it's a bad thing. That's a limit on my free will. No, I decided to do it. I just pre-decided to do it, but it was still me. It was still the outcome of my learning, right? Yeah. So, so there's that, really, really habitual scenarios. And then at the sort of far end, you've got completely novel scenarios where you're just kind of initially at a loss. You don't really know what to do. But you're probably constrained by some sorts of factors in the environment and your history and so on. So it may well be partly randomly that some ideas occur to you, some possible things to do, and probably in conversation this is most obvious, right? Yeah. Why do we say the things we do? They occur to us to say, and sometimes we just say them, and sometimes we think about whether we should say them or not, right? So there's sometimes more deliberation than other times. But what pops into our minds to say, again, is a lot of it is just sort of habits of thought. Like we've had conversations before. We kind of know how they should go in general. We may have talked about this topic before and we have something to say, and so we say it, right, for a reason. And we don't have to think too hard about it. But if you ask me a question that really stumps me, I'm gonna pause, right? I'm gonna give it some deliberation and some effort. And a lot of times when we're thinking about actions, what actions we can do, you can think of this in a two-stage way, where there may be ideas that pop into your head of what to do. There could be several competing possibilities in any given scenario, and then they're subjected to this evaluation system. Right? It goes through the basal ganglia and the thalamus, and involves the midbrain and a whole bunch of other brain areas that you can think of as kind of simulating the outcomes, the possible outcomes of those actions, and then saying, well, would that be a good or a bad thing, right? Evaluating them, oftentimes based on prior experience. And then, through that kind of competition, biasing the competition in the cortex for which one of those basically gets control of the reins, and that's the action that's released, while all the other possible actions are still inhibited. So it's a kind of disinhibition of this one action based on that. Now, one of the problems with that is that the action might not turn out so well, right? So if it's a completely novel thing, what you also want to do is monitor the outcome of it, monitor the progress towards some goal that you might have in that scenario. And it may turn out that you're trying something and it just isn't working, and you try something else and it also doesn't work, right? And what do you do then? You go back to the drawing board and you say, give me some new ideas. I need some new ideas to evaluate. And it turns out there are some really interesting neural systems that effectively increase the degree of randomness, the temperature of that idea generating mechanism. At least that's one way to think about what's happening. And that may in some sense be an origin of creative thinking, where you're thinking outside the box, you're widening the search space for possibilities, especially in a scenario where your goals are being frustrated by and not met by the actions that you've chosen so far.
So there's a point in your book where you say that we should keep in mind that decision making is a process, that we should really think about it as a process, and that means that it has duration through time. It's not just an instantaneous thing that happens and we move from one physical state to the next just instantaneously. So why do you think that idea is so important?
Yeah, I think that's really key, and it goes back to philosophers like Henri Bergson, the idea that we shouldn't think of time as these moments of zero duration where there's some defined state of a system, right? Yeah. Because obviously, if you just have moments of zero duration, you're not going to add up to anything. So right. moments have some duration, right? They're not just an instant that is zero width, if you will. So. This gets to this question of, could you have done otherwise? This argument that many people say, well, if you rolled back the tape to some point at which the system is in state X exactly defined at time T, a precise definition, then at time T plus 1, the state will go to X plus 1 or X or Y or whatever it is, right? And that's inevitable given that the state was like that. And my response is to say, well, no, what is this time T? What are you talking about? There is no time T where you can specify the system where it's a completely static state. It's not a state. It's a dynamic flux, right? And that flux has some indeterminacy to it. So it's always some degrees of freedom, always open. You can never say that a system has a completely defined state right now because there is no right now of zero duration.
So, do you think that this in any way connects us to discussions that have been occurring, for example, in cognitive science between what some people call a substance approach to cognitive science versus a process approach based on things like, for example, dynamical systems theory and complexity theory? We might get back to this question later on to dig a little bit more into it, but I've been aware recently of these kinds of discussions, and sometimes I think that the way people look at things really boils down to this sort of framework in cognitive science that they have.
Yeah, I think that's right. I think that's, you touched on a much more general philosophical divide, right, between a sort of a substance view where the ontology of the world it comprises objects with properties, right? And those objects may be doing things, but the important bits are the objects themselves. And a process view is really trying to foreground the processes that are happening. And when we're talking about life, I think that philosophical perspective is key, right? I mean, we started this conversation talking about life as being sets of processes that dynamically persist through time, right? And it's only that continuity through time that defines an organism or that defines a self. So to me, the process perspective is the natural one and the right one to approach biology generally. And when you're talking about how the brain works, it's absolutely a natural way to think of things, and it's one that more and more people are coming around to using. It's partly just because we have empirical tools and computational tools that suit it now. This dynamical systems view where it's less like a digital computer that goes from black to black to black, these discrete little steps. It's more like a flowing sort of pattern of multiple patterns, that's, it sounds sort of wooey and holistic to be with patterns, man. But the great thing is that the mathematics of dynamical systems and those computational approaches give us a handle on those things. It's not hand-wavy stuff anymore. It's really mathematically formalizable and absolutely seems to map onto what the nervous system is doing, right? I mean, we spend a lot of time talking about what's happening in the system, but to map that to what it's doing, I think requires that dynamical systems view, because that's how populations of neurons are taking information in, both bottom up and top down in terms of context, and they're sort of satisficing their own local constraints and configuration, and that whole thing is happening throughout the whole brain. So it's a much more dynamic and it's a much more organic view of how the brain works, and one that I think certainly appeals to my sensibilities much more than a rigid, deterministic, stepwise, algorithmic kind of process.
Yeah, it's really frustrating that some pseudoscientists really like to use words like holistic, because then you hear that from legitimate cognitive scientists, and people, particularly in the West, just think that it's woo-woo or something like that. So,
yeah, no, you're absolutely right. I mean, holism has a bad name, right? And so do some of these terms that we talked about earlier, like meaning and purpose and value. I think they make a lot of biologists are allergic to those terms. They just start to get a little itchy when people mention them. And, I mean, like, if you think about the distinction between meaning and information, we have a super good mathematical definitions of information. We have whole technologies built on it. We can measure it. We can localize it. We can say all kinds of things scientifically about information. And when we come to something like meaning, which I think is key to understanding living things, you can't localize meaning. You can't quantify it, really. You can't say, oh, the meaning is here. You can't even localize it in time. It's spread through time and spread through a system, and the interaction of the system with the environment and so on. And even saying those words out loud sounds wooish, but it's real. Like meaning is what organisms need to get around in the world. Neutral information is not enough.
Yeah. So let me ask you another question about nervous systems, because in the book you also talk about things like indeterminacy and how there's lots of, or apparently there's lots of noise in the nervous system in terms of, for example, how neurons connect to one another and when they really transmit something to other neurons or not, or just cut the signal and stuff like that. So could you tell us more about that, and what is the role that indeterminacy, noise, and so on play in the understanding we have of free will?
Yeah. So, okay, I'm going to get to the role in the nervous system, but I'm going to start with a deeper issue, which is in physics, right? Because I said earlier that people looking at organisms' behavior, one way you could explain it is to say, well, the organism had this goal, it had this intention, it selected these actions based on these beliefs, and it executed this action. Right? That's a sort of a psychological, ethological explanation of behavior. But you could say, well, actually, look, all of that is nice, but really it's just these neural circuits firing, right? The reason it went there was because these circuits fired. If I went into its brain and activated those circuits, I could make it do that. So all this talk about beliefs and intentions and desires is nice, but that's all epiphenomena. The real causation is in the neural circuits. And so that's a reductionist kind of a view. The problem with the reductionist view is, in principle, how do you find a place to stop? What's the right place to stop? Because once you start down that line, you can say, well, actually, look, the neurons firing is just ions flowing around in its membranes. You know, they only fired because these proteins moved like that, and the atoms and molecules did all this. Now you're talking about physics, right? You're down to the level of physics, and this is where, you know, some people, physicists and others, might say, look, the atoms in you aren't magic. You don't magically move them around. You can't change the laws of physics. They're going to do what the atoms are going to do, and the laws of physics are deterministic. You can look at the Schrodinger equation and say, look, you've got some system, quantum fields and particles, and the Schrodinger equation is completely deterministic as to what the next state of the system is going to be, and the next and the next and the next. And of course, you get to this Laplacian kind of view of the block universe where, you know, there isn't even an arrow of time. Basically, everything that happened was determined by what preceded it, without any options of choices or anything else that could have happened, and all the way into the future. So it's just
and basically, if you could know the position of every particle in the universe in a given moment in time, you could 100% predict the next moment in time, something like that.
And the problem with that is that, well, not a problem, it's just not right. You know, I mean, physics itself says that that view isn't correct, because while the Schrodinger equation gives you a really deterministic prediction of the next state of the system, it's giving a prediction of a probability density function, which is basically, if you ran this experiment 100 times, you could predict really well the statistical outcomes that you would get. However, if something is only happening once, then within that probability function, the actual outcome is apparently random to a certain extent, right? So, and there's lots of sort of, you know, discussions in physics about the interpretation of that and what that means and where that, you know, where that indeterminacy comes from. Is it some hidden variables that we don't know about? Is it many worlds where everything that could happen is happening in some other world? You know, the upshot is that physics doesn't say that the next state of the system is completely determined by the current state and the low-level laws of physics. It just doesn't. Right? So some fundamental indeterminacy at the quantum level, and there's indeterminacy at classical levels as well, but there's a whole sort of argument about mathematics, philosophy of mathematics that underpins that, and it might be too much to get into. So, but anyway, let me just say that physics by itself doesn't say that the system is determined. So there's some indeterminacy. Now, a common rejoinder to that argument would be, okay, well, that doesn't help me. That's not giving me free will, right? Either the system is determined by physics, all the atoms are going to do what they're going to do, and I'm not in charge, or it's partly determined by the laws of physics and partly by randomness, and the atoms are still doing whatever they're doing. It's just sometimes a bit random. I'm still not in charge of that, right? And I think that that's right as far as it goes, because the randomness doesn't give you agency or free will, but it opens the door, right? It means that things are underdetermined at the low level. They're underdetermined, and as a result of that, that means that some other things. Sorry, excuse me for one sec.
No, for sure.
It means that some other things can determine what happens in the system, can determine what happens in the system. And those other things can be the higher order organization of the system. So, so really, it's not determinism, actually, that's so much the problem, or that is the thing that people are leaning on when they say there could be no free will because things are just going to happen. It's really reductionism. It's really saying, look, all the causes are at the lowest levels, and everything that happens above that is fully explained by what happened at the low levels. And the counter argument is to say, no, we're underdetermined at the lower levels, and over time, the configuration of the system can constrain what's happening at the lower levels, just like the shape of a pipe can constrain the flow of water molecules, right? It's not magic. It's also just physics. It's just organizational physics. It's just systems physics, right? So, so what that means is that indeterminacy in the system gives some scope for higher order organization to have some causal power, some causal slack in the system, as philosopher George Ellis calls it. Now, in the nervous system, in general, what that means is that the system can be configured, can become configured in such a way that an organism can do things for reasons. And those reasons are inherent at the level of the patterns of neural activity. What we were just talking about in terms of dynamical systems, population, neural activity, they mean something to the organism, right? And the meaning is interpreted. Sometimes it's interpreted through a behavioral control policy very directly. You know, if I taste something that's really, really bitter, my control policy is spit it out, right? I mean, that's an immediate kind of almost a reflex, right? But other times it's a much more cognitive, sophisticated interpretation. Something means, right? I have a pattern in my brain right now that is my internal representation of your face existing in the visual world right now, right? And I'm going to use that information in directing my behavior, but it's not a stimulus response kind of a thing. It's much more sophisticated. So the randomness at the lowest levels in the first instance allows that kind of meaning-driven causation to occur. However, there's also cases where the randomness itself can kind of be used by the system. And in fact, we already referred to one, this idea of the search, widening the search space of ideas of what to do can rely on some randomness. And actually, there's a famous example in neuroscience, which has been really, really over-extrapolated, which are the so-called Libet experiments. The setup, so the setup is that somebody is asked to, they're hooked up to an EEG, so recording their brain activity, and they're hooked up to a device that's detecting when they move their wrist. So all they have to do is sit there and move their wrist. Literally on a whim, right? They're directed to do it on a whim. And it's a weird thing to do, right? There's no reason to do it. It's a completely inconsequential decision. And so the finding has been that if you look at their EEG recording over time, you can see that when they have, the points that they've made a decision, if you look backwards through time, you can see this ramp up of EEG activity up until the point when they make a decision, right? So if you look backwards from that point, it looks like this activity is ramping up sometimes hundreds of milliseconds or a second or two before they were even conscious of the desire to move. So they also report when they felt the urge to move. Right? So they usually feel the urge to move before they move, but way after this readiness potential starts ramping up. Now, that's been interpreted as showing, well, look, you're not making decisions at all. Your brain is making the decision, and then you're feeling it consciously, but you were never in charge of that thing. And there's a few counter-arguments. One is, even after they feel the urge to move, they can veto it, right? So they can decide not to do it. Two, the way the data were analyzed are, they create an artifact by locking it to only the situations when a movement occurred. You see this gradual ramping up. But if you look, you know, if you give some random sort of thing every once in a while, and then you phase lock that random thing, then what you see is actually those neurons are kind of noisy, right? They're going up and down all the time. And sometimes the noisiness can sort of accumulate until it reaches a threshold and then an action occurs. So it seems like our interpretation of what's happening is actually these participants in these experiments didn't give one fig as to when they move their hand. They have no reason to care. So they basically let their brain decide, right? So they said, okay, actually make use of the noisiness of some neural populations and just allow that to reach a certain threshold, at which time they feel the urge to move and they do so. And in fact, you can design other kinds of situations where people are doing the same sort of thing, but it's a decision that they do care about because they're actually money's being given to charity, for example. This is experiments by Yuri Maus and Liad Mudrak and others. And there you don't see this locking to the readiness potential. So when people actually care about it, then, yeah, you can't say, oh, it's just these noisy neurons deciding. The person really is deciding. So all of that is a long-winded answer, Ricardo, to your question about what, you know, the role of indeterminacy in the nervous system. So in some cases, it's I think, used very explicitly to break a deadlock. In some organisms, it's used to be unpredictable, right? I mean, we have a collective noun for organisms whose behavior is predictable, and that is lunch. They're just going to be dead, right? You're too predictable, you're going to be dead. So a lot of organisms, especially in escape responses, when they have a threat, they actually implement a kind of a random decision-making process, neurally speaking, that will determine the direction of their escape response. So so randomness can sometimes be used like that, can sometimes be drawn on as a resource in our own reasoning, especially sort of when we're looking for more creative ideas. But more generally, it opens the door to us deciding to do things based on our reasons, based on the meaning of patterns and our beliefs and desires and our knowledge and understanding about the world.
Mm-hmm. So you mentioned the Libet experiments there, and at least as far as I'm aware, those were done with participants whose brains didn't have any sort of issue, I guess. So, but there are also lesion studies, and sometimes people bring up those examples of people like, for example, that they had, for example, some lesion in their prefrontal cortex or some brain tumor growing there, and they couldn't really control some of their violent impulses, for example, and committed crime, homicide, and stuff like that, and were arrested for that. I have to tell you that until a few years ago, people who use those sorts of examples, I took them seriously as having some sort of bearing on these discussions surrounding free will and really telling us that determinism is the correct view here. But then, I had discussions with other people, particularly over the past 2-3 years, and they really pointed to something that, now it's obvious to me, but until very recently it wasn't that is. But you're talking about people who have damaged brains. So, right? We're not talking about people whose brains are functioning normally. Right.
Yeah, and I think that's right. And so there's two ways to think about this. You can look at those cases like that and you can infer from those extreme cases evidence that generally we're not in control, right? Mm-hmm. So you can say, well, look, it's because this person's brain was like that they did this thing. Therefore, everything that we do is because our brain is the way that it is, right? And I think that that's not the right conclusion to draw, and I think that's the position that you come to as well, right? However, I actually think those cases are good evidence for free will, for thinking about it as an evolved capacity, the capacity for conscious cognitive control that characterizes human beings, and for understanding that that capacity isn't magic, right? It requires some neural machinery. And we can use that kind of evidence to say where that neural machinery might be located and how it operates and what are the parameters that it cares about and acts on in helping to guide our decision making. So, for example, with lesions in the prefrontal cortex, depending on where it is, a person may become highly impulsive. So they lack the ability to plan over a long time period. They lack the ability to prioritize long-term goals over short-term ones. They're going for immediate gratification. They're much more impulsive and so on. While lesions in other parts of the prefrontal cortex can impair the ability to do anything, right? Just the drive to act at all, right? So you can kind of, using those things, you can tease apart the neurobiology of free will, if you want to call it that, right? And that's the philosophically loaded term. If you want to say the neurobiology of conscious cognitive control, then fine. But that's what I'm talking about when I'm talking about free will. I'm talking about that capacity, and it clearly is evolved. It clearly depends on some neural machinery, and that neural machinery can become damaged. So I don't think that those kinds of cases are evidence against free will. I actually take them as evidence that informs our understanding of it as a biological capacity.
Mm-hmm. So now I'm going back to something we talked about in our first interview back in 2019. You wrote a book called Innate, and I'm also leaving a link to that in the description of this interview. We have certain psychological predispositions that to some extent have some sort of genetic influence behind them. And I mean, and in this case, the sort of question I want to ask you, it doesn't even matter much if they are mostly genetic or mostly environmental. I mean, it doesn't matter much, but they are sort of influenced by something.
Yeah.
And I mean, thinking about that, and I have to tell you that this is one of the things that really makes it harder for me to really buy the entirety of the argument in your book, because perhaps it's just the way I think about free will. Perhaps in some ways it connects again to that dualistic kind of thinking we mentioned at the beginning of this conversation. But do you think that that could pose an argument or a counter argument to the kind of argument you're making in the book, that wherever these predispositions come from, genes, the environment, that they're still there and we don't have really conscious control or agentic control over them?
Yeah, absolutely. And I think that's a really key argument. I think what's important is to distinguish that argument from arguments about sort of neural reductionism or physical reductionism, or determinism, right? So here we're talking about the more of a biological fatalism almost. The idea that we're wired a certain way, and as you said, the previous book that I wrote was all about that. The idea that we're not slates due to genetic variation and developmental variation. We're born with our brains wired a certain way. That leads to individual differences in human nature, which we recognize as personality traits or cognitive capabilities, and so on. So absolutely, we do have predispositions psychologically. We do differ from each other in terms of personality traits, and personality traits are defined by patterns of behavior, right? I mean, that's what we mean when we say someone is neurotic or extroverted or conscientious, is that they behave in those ways, right? Ways that we just label with those terms, right? So absolutely, it seems like a challenge to the idea of free will. And what I will say, first of all, is that it's a total challenge to the idea of absolutist free will. But I hope that, where we started this conversation by saying that kind of absolutist free will is incoherent and really is a dualist sort of view, that's not such a worry. And I'm not arguing for absolutist free will. I'm arguing for this evolved capacity to make decisions for reasons based on our understanding and knowledge of the world, and to act as causal agents in the world. Now,
so let me just interrupt you there for a second. So if we set up a scale from 0% to 100% free will, what you're saying there is that you do not agree that we have 100% free will, but neither do we have 0% free will. It's something like that.
Exactly, and it's partly why I didn't want to start the book with a definition of free will where I was going to either say, yes, we have it, or no, we don't, right? I want to understand what the will entails. What is that? When we're willing something, decide to do something based on our motivations and goals and desires, what does that involve? What are the neurobiological underpinnings of that? And how many degrees of freedom, or what kinds of freedom do we have in those processes that can rightly be said to be held by us as an agent, that aren't just, that aren't properties of our parts, the properties of the as a whole. So yes, we have predispositions. We vary in personality, and a lot of times when people have concerns about free will, really they're saying, well, look, I couldn't have done any differently because I'm wired this way, right? I have a short temper, or I was so nervous and anxious I couldn't, and I wish that I wasn't. I wish that I was different from that, but I couldn't decide not to be anxious. So we don't have control over all of our emotions at any given time. We don't have complete control. That doesn't mean we don't have any control, and it doesn't mean we don't have any control over the way our brains get configured either. So first of all, we do have the ability of rational control over our impulses, right? We're not just completely impulsive, and in fact, this develops through time, through our lifetimes, right? Babies are completely impulsive. They're just
Yeah.
driven by their impulses. And children and toddlers are still quite impulsive, but they're learning to control those impulses through rational thought. They're learning to delay gratification. They're learning to put other people's goals, take them into account, put them above their own goals sometimes. And those are all capabilities that mature. They're skills, if you will, that take practice to do. But they're real, right? And we were talking about the prefrontal cortex, and a lot of the sort of executive functions that the prefrontal cortex is responsible for are like that. They're us exercising rational control over our immediate impulses. So it's not the case that we're always just driven by these underlying predispositions that we're born with. I mean, I tend to think of those as sort of like the tunings of certain circuits, that maybe our risk aversion circuit is tuned a little higher, maybe our confidence thresholds for action is tuned a little lower, maybe our delay discounting, which is how much you discount a reward based on how far it is in the future, maybe that's tuned higher or lower. And we can actually tweak those kinds of things in animals now. Like there's a very sophisticated cognitive science even in animals of those kind of decision-making parameters and how they broadly feed into patterns of decisions, right? But it's patterns of decisions over time. It's like talking about the climate of a country as opposed to saying the climate determines right now on a moment-to-moment basis whether it's raining or not. It doesn't, right? That's talking about the weather. Yeah. So personality traits I like to think of more like the climate, right? They're broad statistical descriptors of patterns of behavior over time. They're not immediate things pushing you like this and like that. Most, of course, you can draw on occasions where those impulses did drive behavior. But again, I wouldn't. If anything, those are ones that highlight the fact that most of the time we're not like that, right? Yeah. So one of the kind of interesting ideas, I think, is this idea of whether we have any control over these prior causes, whether we had any involvement or responsibility for the way our brains are right now. Right. And many people would say no. They would just say, look, it was genetics, it was developmental variation, and then a bunch of experiences happened to you, and they shape the brain to be the way it is right now at this instant, and you can't do anything about that, and you had no hand in it or responsibility for it. And I think that's simplistic, and I think it's wrong. So we have some agency, and we get, I think, more agency as we get older, right? Again, babies don't have much agency. Little children have some, but as we get older, we have more autonomous self-control over our own actions. We can plan further into the future and so on. Part of that planning is adopting policies. It's learning habits and so on that affect our behaviors, but it's also actively thinking about policies. What kind of a thing is good to do? Making commitments to long-term projects that guide our behavior in the moment. So if I decide to go to college, that's a constraint. My past self has decided that, but it was my past self, right? It wasn't somebody else. So that's a constraint, but I was involved in setting up that constraint that configures my nervous system right now. So I think you can think about those commitments and policies and attitudes and so on. And you can also think about, beyond personality traits, you can think about character traits. And those people, they don't sound so scientific, right? They're not so popular in psychology to talk about traits that, things like kindness and honesty and bravery and patience and temperance and forbearance and, being just and fair-minded and things like that. There's a normative aspect to those that isn't there when we're talking about, say, neuroticism or extroversion or openness. Those are sort of traits. It's not necessarily good or bad to be high or low. In fact, variability is probably good across the population. But for character traits, we have really their virtues or vices. And I think we're involved in the development of our own character. I don't think that just happens. I don't think it just emerges from forces outside us. It emerges partly due to the decisions that we make as agents through our lives and the accumulated sort of effects of those and the forward-looking sense in which we decide what kind of a person do we want to be. So we can look at our own motivations. Right? For people who say, oh, we can do what we want, but we can't want what we want. We can't decide what our motivations are. We decide what our motivations are all the time. We're always thinking about our motivations. They're not opaque to us. We're constantly talking about why we did things. And we're often examining, was that a good reason for me to have done something? And to say, actually, no, it wasn't. So in the future, I'm not going to do that. I'm not going to be the type of person who acts in that way. And a lot of sort of civilizing influences of society are aimed at that process. And sometimes it's overt indoctrination, like in religious instruction, for example. But a lot of parenting is the same sort of thing. It's like, you shouldn't hit your sister. It's nice to share food with everybody. You should think of somebody else. You should have seen that was going to happen. You should have planned for that. Those kinds of things are all inculcating and helping to build up character traits that really, we see them as good or bad because mostly the good ones are pro-social, right? So they actually are the underpinning of our society and civilization. But also they tend to be ones that involve inhibition of impulses and a greater degree of rational control.
So I have two more questions then. And by the way, let me just mention, because I find this very interesting, it's been, you mentioned there in your answer things like constraints, and we've already talked about it twice in the interview, I think, and someone that has been doing great work on constraints and how they are related to causation is Alicia Huarero. And hopefully I will have her on the show this year. She has a great book, Context Changes Everything, from this year. And I really find it fascinating how thinking about constraints can also help us reframe, also in terms of psychology, how we think about top-down causation.
Yeah. Right? Oh, absolutely. So Alicia Huarero, I really would recommend that book. Context Changes Everything. It's fantastic. And her, I've drawn on her work and the work of other people like George Ellis and Helen Stewart and so on, and thinking about top-down causation, where it doesn't have to be mysterious. If there's some causal slack or underdetermination at the lowest levels, then the way things are organized can have causal power in and of itself. And if you think in the nervous system, that manifests as patterns of neural activity having causal power because they mean something, right? So you can have a population of neurons that has some pattern of neural activity and say, well, that pattern is just driving the next neurons that are being innervated by it. But a different way to look at that is to say, well, actually, we've got one set of neurons up here that's monitoring this as inputs, right? That's its sensory input, basically.
Yeah.
And it can be configured in such a way that if this pattern here corresponds to a macro state, right? Not the details here, but it fits state A, then this system here will have one response. But if it fits state B, it'll have another response. But it may be, there may be loads of micro states. Those are detailed patterns here that all correspond to state A or state B. So you have this system of multiple realizability that means that it's right to think of the meaning of the pattern as having the causal power and influence in the system. And that reduction to neural activity isn't right, because you can have a counterfactual idea to say, well, it's not just all the details of neural firing that were important, because I could change those details and you'd still get the same effect. It's only when I change the details in a way that changes the meaning that I get a difference. And so there you've got a contextual, configurational kind of causation that's perfectly physically reasonable. It doesn't violate any laws, but it shifts the perspective of thinking from a driving to a monitoring view of neural activity. And so that's one way where thinking of constraints, right? Constraint is the configuration of the system is what it is right now. That's there for a reason. The reason is it interprets the pattern of activity to mean A or B, right? So that's just how the nervous system works, in my view. The meaning drives the mechanism. The other aspect of it is a more psychological one, and it gets back to the question that we started with about absolutist free will. So the person who seems to be wanting absolutist free will seems to want to be able to do things with no prior causes whatsoever, which means no constraints on them whatsoever.
Yeah.
Now, if you think about that for a minute, what that means is no reasons, no causes, no influence of sensory information, no goals for a future self, nothing learned from a past self. It's just doing things for no reason, right? Any reason is a constraint or prior cause. It has to be, right? Mm-hmm. So it becomes really incoherent, but also what it does is it highlights the fact that you wouldn't be a self. An object that behaves like that would have no continuity through time, right? The only thing that makes us selves recognizably is having some continuity behavior through time, right? You behave like Ricardo through time. I behave like Kevin through time. If we didn't, right, if we started behaving out of character, then people would quite rightly worry about us, right? And people with mental illness, people with psychosis or mania or depression, they stop behaving like themselves, right? So selves, to me, just are constraints. There's nothing else it means to be a self except to have some constraints through time. That continuity comes from that, and we shouldn't. Those are enabling constraints, right? We shouldn't think of constraints just in a negative way. We're nothing but constraints.
Yeah. So, in the interest of time, let me ask you just one final question then. And at a certain point there, you've already mentioned or alluded to the link that we many times establish between free will and moral responsibility. And I mean, I mentioned psychological traits or psychological predispositions earlier, and I said that's one of the points that really makes it harder for me to fully accept your argument. But perhaps this one makes it even harder, because this might be a bias that we have, but I mean, I find it really hard to not say that some people who, for example, live in dire situations, like, for example, the poor, the downtrodden, and all of that, to not say that, I mean, what we find in their lives, the result of their actions or whatever, it's not really their fault. And sometimes also people who just get lucky to try to remove some free will from there because, oh, you don't deserve so much, come on, you're just lucky. So I mean, I know that in the book you say at a certain point that trying to look at or avoiding this link between free will and moral responsibility is good because it usually muddies the waters here. Yeah. But still, we have this, many times, this intuition, this very strong intuition to say, oh, come on, it's not their fault, or you've just been lucky, and so on. So how do you think we should deal with this?
Yeah, so what I wanted to do in the book was take apart this question of free will from the question of moral responsibility, because I think moral responsibility adds a whole level of complicating, confounding factors that are separate things unto themselves, right? And if you tie them together completely, if you're always talking about free will in the context of actions being praiseworthy or blameworthy, deserving of punishment, then you've conflated these one complex thing with another complex thing. Right, so I wanted to pull them apart and ask, well, what kind of freedom do we have? What does the will entail? What does that really look like? And part of the question then is, once you get a sense of that, you can say, well, how can that freedom be impinged? Right? How can it be curtailed by either our personality traits, which absolutely do place constraints on our behavior, or things that are external to us, like our external circumstances, like dire poverty, or particular situations where we didn't really have much of a choice, right? And so really where I landed on this in terms of thinking about what are the implications for what I'm saying, for our views of moral and legal responsibility, actually I think the implications are we already have pretty good views of legal and moral responsibility, right? So our legal system already makes allowances for people's situations. It makes allowances for how mature they are, for how old they are, because we know that children don't have the ability to rationally control their behavior as much as adults do, right? Yeah. It makes allowances for people with mental illness or mental handicap. It makes allowances for, exigent circumstances that someone might have been under in the moment. So I think we already do that. And really what I wanted to do was push back a little bit against the people who are saying, oh, free will is all an illusion, and our entire legal moral system kind of crumbles as a result of that because it's not founded on anything at all.
That's, for example, the argument that Robert Sapolsky makes.
It seems to be, right? And so I don't think that those implications are right. I don't think we have to worry about that. I think we have very sophisticated legal systems in particular. They're not perfect, and there's always going to be cases where you can make, you can say, well, look, this wasn't really totally their fault, and yet it was kind of partly their fault. And, judges have to make judgments. That's what they're paid for. If it was easy, we could let GPT-4 make all the judgments. But it's not. It's not easy. Those things are all really complicated and nuanced, and they're very, very context dependent. So really, I guess if I have a mantra, it's to stay away from any absolutist kind of framings or absolutist implications, because I don't think there are any.
Mm-hmm. So basically, just to make this point clear, what you're saying is that the argument I was making, you're not really against it, and even more than that, we already consider those things when wanting to blame or praise other people or punish them legally, for example.
Absolutely, and I think it's fair to to look at some people, especially when we're doling out praise for achievements, for example. Many people take what are really based on genetic or social endowments or social capital and so on, and they say take as evidence for a meritocratic kind of society and say, look, I did this, anyone can do it, without really acknowledging the role of good fortune in their own lives, in their genetic makeup or their social circumstances or whatever. So yeah, I think there's all sorts of needed nuance in here when we can learn things about human behavior and where the forces that influence it, without falling into the trap of thinking of them as forces that determine it, right? And that's the difference. We can acknowledge that there are influences without saying that means the agent is not doing anything, right? That it's just being pushed around by those configurations. I don't think that's right. It's being influenced by them, but not determined.
Great. So the book is again Free Agents, How Evolution Gave Us Free Will. I'm also leaving a link to it in the description box of the interview. And Dr. Mitchell, apart from the book, would you like to tell people again where they can find you and your work on the internet?
Sure, yeah. So I have a blog called the Wiring the Brain blog. I haven't been writing that much on that recently because of the book, but I hope to get back to it soon. I have a site called kjmitchell.com, where there's other scientific publications and so on. And then I'm on Twitter at Wiring the Brain is my handle on Twitter. Always happy to chat.
Great. So thank you so much again for taking the time to come on the show. As I said at the beginning, it's always a pleasure to have you on. And I really loved the book. I recommend it to everyone. And I guess that after reading the book and after this conversation, perhaps the way I differ from you would probably be only in terms of the percentage of free will that we attribute to people. Perhaps you attribute, 70%, and I attribute 65%.
Yeah. Well, that's good. All right, that's a win. I'll take that. And plus, I think that's not a fixed number, right? I think that varies. It varies over people's lifetimes. It varies across people, and it varies in different scenarios. So, yeah, again, it's not fixed, it's not determined, all very fluid. But anyway, that's great to hear, Ricardo, and it's been a pleasure. Thanks a lot for having me on.
Okay. Yeah. Hi guys, thank you for watching this interview until the end. If you liked it, please do not forget to like it, share, comment, and subscribe. And if you like more generally what I'm doing, please consider supporting the show on Patreon or PayPal. You have all of the links in the description of this interview. This show is brought to you by Enlights, Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters: Per Erga Larsen, Jerry Muller, Hans Fredrik Sunda, Bernardo Seixas, Olaf Alec, Jonathan Visser, Adam Kessel, Matthew Whittingbird, Arno Wolf, Tim Hollis, Henrik Alenia, John Connors, Philip Forrest Connolly, Robert Windager, Rui Inácio, Zup, Marco Neves, Colin Holbrook, Simon Columbus, Phil Kavanagh, Michael Stormir, Samuel Andreff, Francis Ford, Tiago Dunes, Alexander Dunbauer, Fergal Cusson, Hal Herzog, Nuno Machado, Jonathan Librant, João Linhares, Stanton T, Samuel Correa, Eric Hines, Mark Smith, João Weira, Tom Hummel, Sardus France, David Sloan Wilson, Yacila Dez Araújo, Romain Roach, Diego Londonho Correa, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavlo Stasevski, Nelek Bach, Guy Madison, Gary G. Hallman, Sam Afzal, Adrian Yegi, Nick Golden, Paulo Tolentino, João Barbosa, Julian Price, Edward Hall, Edin Bronner, Douglas Fry, Franca Bortolotti, Gabriel Panos Cortez, Ursula Litska, Scott, Zachary Fish, Tim Duffy, Sonny Smith, John Wiseman, Morten Eklund, Daniel Friedman, William Buckner, Paul George Arnaud, Luke Lowacki, Georgios Theophanos, Chris Williamson, Peter Olsen, David Williams, Diogo Costa, Anton Erickson, Charles Murray, Alex Shaw, Amaury Martinez, Coralie Chevalier, Bangalore Atheists, Larry D. Lee Jr., Holt Ericbun, Sterry, Michael Bailey, Dan Sperber, Robert Grassi, Tom Roth, DRPMD, Igor N., Jeff McMahon, Jake Zool, Barnabas Radix, Mark Campbell, Richard Bowen, Thomas Dobner, Luke Neeson, Chris Story, Manuel Oliveira, Kimberly Johnson, and Benjamin Galbart. A special thanks to my producers, Cesar Webb, Jim Frank, Lucas Stafiniak, Tom Vanagdam, Bernard Hugni, Curtis Dixon, Benedict Mueller, Vega Guidi, Thomas Trumbull, Catherine and Patrick Tobin, John Carlo Montenegro, Robert Lewis, and Al Nick Ortiz, and to my executive producers, Matthew Lavender, Sergio Quadrian, and Bogdan Kanivets. Thank you for all.